Hello, it's another A-level maths video. We're looking at types of data in this video, section 1.4 of the Statistics Year 1 textbook. So in this video, we're going to be learning lots of definitions, qualitative, quantitative, discrete, continuous, and some other words as well. So let's get started. So here we go then. Here's our first couple of definitions to know. When data is numerical, it's known as quantitative data. And when data is non-numerical, it's called qualitative data. Some textbooks call it categorical data, but I'm going to call it qualitative data. So here's a quick example just to clarify what that really means. Let's say we've got a researcher, they're collecting data regarding vehicles in a car park, and they're going to collect lots of information about these vehicles. We're just going to see whether this is quantitative or qualitative data. So the color of the vehicles. Well, color, that's not a number, is it? Colors are things like red, green, blue. So those aren't numbers, they're not numerical. So that must be qualitative data. So the color of the car or the color of the vehicles is qualitative data. Number of doors, however, I think, well, you count the number of doors. The number of doors on a vehicle might be 3, 5, 4. So that's definitely numerical data. And so that's quantitative data. Pretty straightforward, I hope, but let's just test to make sure that you're okay with this. There's some more things about these vehicles on the screen here. I want you to decide whether these are qualitative or quantitative data. Okay, then let's see if we can add to our list then about these vehicles in this car park. So the first one here, engine capacity. So that's things like, is it a 1500 cylinder engine? Is it a 2000 or whatever? That's a number. So that's definitely quantitative. So the capacity or the size of the engine is numerical. Okay. Length of the vehicle, how long is it? Well, we measure how many meters long or how many centimeters long. Again, we're going to get a number. We're going to get that length here. So the length of the vehicle is numerical and quantitative in that case. And then the final thing we had there to think about was the seat cover material. So the material, what kind of material is this? Well, that's not numerical data, that's not quantitative, it must be qualitative data here. So the seat cover material is qualitative. Okay, so if you think about it and just use your common sense, you should be able to work out whether data is qualitative or quantitative. Now, the vast majority of the data that we're going to be dealing with in our A-level maths course is going to be quantitative data. It's going to be numericals because we need to sort of do those calculations with it. And quantitative data can actually be subdivided into two different types. We can have discrete data or we can have continuous data. Discrete data can only take exact values. Continuous data can't take exact values and can only be recorded to a certain degree of accuracy. And to make sense of what that means, we'll just look at another quick example here. Let's say we're doing a survey and we're asked for certain information about the people who respond to that survey, the respondents of that survey. Let's see if we can work out whether or not we've got discrete or continuous data here for these two particular situations here. So the first one we're going to look at is height, a person's height. Well, we're measuring that, and it means that the height is never going to be measured to a precise exact value. If I were to tell you, for example, that I am 178 centimeters tall, I don't mean that I am precisely exactly 178 centimeters tall. I mean that I'm somewhere between 177.5 and 178.5. So when I say 178 centimeters, I'm not being precise. I'm not giving you an exact value. So height is an example of continuous numerical data, continuous quantitative data. I hope that makes sense to you here. Think about it if you need to. Shoe size. Now, if I go to a shoe shop, I should say, if I go to a shoe shop, I'm only going to see, size 8, size 9, size 10. I'm not going to see, those in between sizes. I suppose there are some shoe shops, it might sell a size 9.5 shoe or something like that, but that's still an exact value. I go to a shoe shop and I get an exact shoe size. I don't sort of say, well, I want, when I buy a size 9 shoe, it doesn't mean I'm getting somewhere between like an 8.5 and a 9.5. I mean, I'm getting a size 9 shoe there. So shoe size is an example of an exact value, so therefore that's discrete data. And I'm hoping that makes sense. So in a second, I'm going to ask you to pause the video and think about the situations that I've put on the screen now. Decide whether or not these are discrete data or continuous data. Okay, what do you think here? Well, let's go for them one by one. Weight, somebody's weight. Well, that's continuous. When somebody gives their weight, let's say they are 78 kilograms, that doesn't mean they are precisely 78 kilograms. It means they're somewhere between 77.5 and 78.5 kilograms, and it's just been rounded to that number because that's a convenience number to round it to. So that's continuous. Number of siblings, number of brothers and sisters they had, well, that is discrete. Number of siblings here. And the reason why that is discrete data is because when you can't have like an in-between number. When someone says they've got 2 siblings, they mean they've got precisely exactly 2 siblings. They don't mean somewhere between 1.5 and 2.5, do they? They mean exactly 2. And then the last one here, age in completed years. Well, that is going to be discrete data. It's basically how many birthdays have you had, So if you are, for example, 18 years old, your age would be 18 in completed years. It's not, if you've had 18 birthdays, you haven't had like 18.1 or 18.3 birthdays. You've had exactly 18. That's discrete data. So it's not always obvious, I think, when data is discrete or continuous, but we do need to be aware of it because we do treat these things in very, very different ways. Okay. Let's move on because there's another situation which I want you to think about here in this video, which is going to lead us into a few more definitions we need to know for grouped data here. Have a look at the question on the screen, pause the video, have a think about it, and once you've got your answer, restart, please. All right then, let's make sure we understand what's going on here. If Michael's time was recorded as 50 seconds, now I think relating this back to what we were just talking about, I think the time of these athletes running this race is going to be continuous data. So 50 seconds does not mean precisely exactly 50. What it actually means is that it's somewhere between 49.5 to 50.5 seconds. Anywhere between 49.5 and 50.5, we would record to the nearest second as being 50 seconds. And it's important we understand that that's the situation when we are presented with data in a grouped frequency table a bit like this, particularly continuous data. So here's an example where we're looking at these athletes running these 400 meters. We've recorded their times to the nearest second, and it's been summarized in the table below. So we need to be really, really clear what this table is telling us. So one thing it is telling us here, let's just focus on one of these groups here. Let's look at the 50 to 54 group here. Now, let's bring in some technical words here. We would call that not a group, actually. We could call it a group, but the technical word for that is a class. So we have these different classes. That's the word that we use to represent each group or to describe each group in a grouped frequency table like this. The 50 to 54, it doesn't mean that the two athletes that ran 50 to 54 actually ran between 50 to 54. It actually means they ran between 49.5 and 54.5 seconds. And the reason for that is because these numbers have been rounded. So anything sort of, which is slightly above 49.5 might have been rounded to 50. Anything which was slightly below 54.5 might have been rounded to 54. So when we see 50 to 54, we need to be aware it actually means 49.5 to 54.5. So watch out for that. So it's useful to have some words to describe these limiting numbers, and they're called class boundaries. So this one here, the 49.5, would be called the lower class boundary. And this one here, the 54.5 for this class, would be called the upper class boundary. Okay, does that make sense? Hope so. I'm just going to quickly throw in another couple of words for us to know about here. We sometimes need to know about something called the class width, and that's really just the difference between the class boundaries here. So in this particular case, that would be 54.5 minus 49.5. So the class width would be 5 here. That's kind of like the interval it kind of takes up. So we have like a difference of 5 between these class boundaries. And one other useful idea is to know the class midpoint. And if we want to calculate the midpoint, we just go for the number exactly halfway between the class boundaries. And the easiest way to work that out is actually just to work out the mean of those two numbers. So if I take 49.5, add it to 54.5, and then divide that by 2, we get the class midpoint, which I think in this particular case is 52. So on the screen now, I've just summarized all of those definitions for you. I won't read them all out again, but pause the video if you need to. Just make sure that you understand what we mean by these words, because these are words that you need to be very familiar with. Okay, think you know what's going on here? Have a go at this question, please. Pause the video and restart once you've got your answers. Okay, how did you get on then? So the 60 to 64, what it actually means here, it doesn't mean 60 to 64, does it? Because these numbers have been rounded. It actually means 59.5 to 64.5. Okay, hope we understand why. The lower class boundary, therefore, is this number here, the number above which it takes us for it to be in the class here, so 59.5. The class width would be this number here minus this number here. So 64.5 minus 59.5, which is 5. And then finally the midpoint, if we take the average of those two class boundaries, so I'll add them together and then divide by 2. And I think therefore we get the answer 62 is the midpoint of that class. Finally then, let's see if we can just bring all this together. I've got a question on the screen for you to have a go at. Pause the video, answer the questions and restart once you've done. Okay, so here are the answers. This particular data, we're looking at the distance that employees travel. This is going to be, certainly it's going to be quantitative data because it's a number. So quantitative, always have to think about how to spell that word. There we go, quantitative, yeah. And then is it discrete or is it continuous? Well, I think this is continuous. And the reason I think it's continuous is because we're looking at distances here which are not measured as exact numbers. If I traveled, let's say I traveled 8 miles, that doesn't mean I've traveled precisely exactly 8 miles. It just means sort of, you know, between 7.5 and 8.5 miles. Okay, so we've been asked to say something about the 15 to 20 class. So the one labeled between 15 and 20. So the class boundaries here. Now, interestingly, we don't have to sort of do the 0.5 adjustment for this situation because the way the data has been presented is we haven't rounded the numbers to the nearest whole number first. So the 15 to 20 means that actually the lower class boundary, I'll just write lower, is actually that 15, and the upper class boundary is actually the 20. Those are the limiting numbers. Those are the numbers between which we are in this particular class. So hopefully you understand why in this particular situation we didn't need to do the 0.5 adjustment. Sometimes you do, sometimes you don't, and you need to watch out for that. And then finally the midpoint. Well, the midpoint is the average of these two class boundaries. You should have worked that out to be 17.5 miles there. Okay, so lots of definitions, lots of vocabulary that we need to know in this video, and obviously we'll be making use of all of the vocabulary and all of the things, all of these ideas as we go through our statistics work. And it's very important that we do understand whether data is discrete or continuous. We do understand about these class boundaries, how they work, because it's going to affect how we analyze the data later on. So get yourself a bit more practice on this. Have a look at exercise 1D in the textbook. It's on page 10. Do as many questions as you can, and I'll see you in the next video.